Okay guys, an example here with our greatest integer function. We have a lot going on in this one. And the first thing first, I'm going to write out our parent function, which would be just greatest integer x. And then I'm going to write g of x in terms of f of x here. So the greatest integer bars, right, everything inside that's going to be now in my parent function. So inside f of x, I'm going to have that negative 1/2 x plus 3. And then outside our parent function is just that plus 4. So this is just separating our x changes and our y changes. Okay, before I start doing this one, I'm going to do it with a t-chart this time. I am going to factor that negative 1/2. And I get an x minus 6 left in here. And then a plus 4. I don't think, and I would have to play around, that we can just pull out that negative 1/2. And you guys like play around on Desmos if you have questions like that. You know, put it in, put it out, see what it does, right? But fractions inside greatest integers change thing. If it was an integer inside the greatest integer function, I do think it would change things like horizontal versus vertical, but I do get a lot of those questions, so always feel free to play around. Okay, so I'm going to do a little t-chart. Let me actually let's use a blue here. All right, so my original points I'm going to have here. And for the greatest integer function, I actually like to do points like on the original that aren't included. And my graph's kind of tiny over here. But like our greatest integer originally looks like this, right? Close to open, we've got these points. So I like to do 4 points for the greatest integer, and I put a dot. So this is going to be a closed point at 0, 0, but then an open circle it was 1, 0. On the original, we have another closed circle at 1, 1, and an open circle at 2, 1. So I like to go through and just put 4 points that I know were open or closed for these. And I really actually like graphing greatest integer just using the transformations on the graph. So that's another option. So I'm going to erase these originals, erase some of my grid line there, but that's okay. Okay, so now I'm going to go through the changes. Our y changes are really nice and easy for this one. We just have that plus 4 on the end. So my y's, I'm just adding 4 to all these values. My x's, however, have a lot of changes. And I'm going to start writing up top what they would be on the graph. So this one would be up 4. My x's, we would have a horizontal reflect because of that negative. We would have a vertical stretch of 2. And we would move it to the right 6. I like to go, if you're doing a t-chart, and make all these changes at once for the x's. So the negative will be there. That 1/2, remember, changes to a 2. Then I've got my x. And then the last thing we do after we've multiplied by negative 2 is add the 6. So I'm going to make these changes to my points. So this guy's going to be 6. Negative 2 plus 6 is 4, 4, negative 4 plus 6 is 2. All right, and now I'm going to put these on, but paying attention to which ones were open and which ones were closed. So at 6, 4, 1, 2, 3, 4, here's 5. 6, 4, here's 5 again. I should have a closed circle. And at 4, 4, I should have an open circle. And since these were, this was my first step to start off, my first little segment that's connected, they're going to be connected here. And it should be a horizontal step, right? So you know if it's on the same y value, that's one of your steps. Now my next step is 4, 5, and that was a closed circle. So 4, 5. And then 2, 5 was an open circle. Once you have 2 steps, then you can just keep your pattern going. So these steps are like 2 units long, and they're only 1 unit spaced apart. And notice that they're going like open to close. That's because our horizontal reflection. So this is a really nice method I like to use for greatest integer, but any method you guys can use to get here is fine.